Variable acceleration worked examples, part 1. So acceleration is given, so we're starting here. We're working out velocity, so we need to integrate. Integrating, we have a constant of integration. Initially, when t equals 0, the velocity was 8 meters per second. We substitute those values in, we work out the value of c, substitute it back in, and we have an expression for the velocity of the body. Starting with the velocity, to work out the displacement, again, we're integrating. Integrate, work out the value of the constant c using these initial conditions. So c equals 0, and we have what we're looking for, an expression for the displacement. So we have a formula for the velocity. The initial velocity is when t equals 0, so substitute t equals 0 into here, we get v equals 0.36 meters per second. In part 2, we're looking for the displacement. So currently we have velocity and we want displacement, so we have to integrate. So integrating, constant of integration. At t equals 0, the particle passes through a fixed point O, so the displacement is 0. Substitute those values into here, so c equals 0. So we have a formula here for the displacement, and when t equals 3, if we substitute in t equals 3 here, we have our displacement, 0.54 meters. Example 3, a maximum of anything on a graph is a stationary point. So on a velocity time graph, dv by dt is equal to 0. The gradient is 0 at a maximum. So if you have a velocity time graph, you might have something on the graph that looks like this. So you have a maximum right there. That's the maximum velocity where dv by dt is equal to 0. So expand the brackets, differentiate, make the derivative equal to 0, and dv by dt is actually acceleration. So where you have the maximum velocity, acceleration is 0. Solve to get t equals 4 seconds, but that's just the time when you have the maximum velocity. We need to substitute the value of t equals 4 into here to get the maximum velocity, 64 meters per second. To sketch the graph, and this is just a quadratic graph, if we solve for v equals 0 to work out roots, so we have two roots, and that would give you a negative quadratic term, so an n-shaped graph. So we have this, and there's the maximum, t equals 4, maximum velocity, 64 meters per second. Okay, so example 4, we have displacement, and if we take the displacement and we differentiate, we can get velocity. And the maximum velocity will be where dv by dt is equal to 0. So we have velocity, dv by dt, which is also acceleration, is this. So I've differentiated, I've made that equal to 0. I'm going to solve the equation. So at t equals 20 seconds, we have maximum velocity. So to work out the velocity, we just substitute t equals 20 into our velocity formula, and we get 80 meters per second. And the distance traveled in this time is given by this formula, s equals, Here it is. Substitute in t equals 20 and we have the distance travelled.